Customer segmentation with PCA and K-means in Python. Welcome! Today you will learn how to group customers using real data. You will use important tools called PCA and K-means. These help discover patterns and clusters in messy information. No experience is needed. Let us explore hands-on. Running the cell now. First, let us keep it clean by hiding warning messages. Next, we get pandas. Pandas helps us work with table-like data easily. Let us start by making sure warning messages will not distract or confuse us. We import the warnings library to handle warning settings. The filter warnings function hides future warning messages. Now, we import pandas. Pandas helps us manage, edit, and show data in tables. Running the cell now. Try running this to make sure you have pandas installed. What is customer segmentation? Companies often want to group customers by habits or traits. Grouping helps them target special offers and better understand shoppers. Today, you will use real shopper data to see clusters and patterns. Running the cell now. Let us load a real mall customer dataset from the internet. We use pandas to read directly from a web link. Shape shows the size, rows are customers, columns are features. Head lets us peek at the first few rows for a little preview. We set up the data by giving the link to the file. This dataset holds shopping info for many people at a mall. We use pd_read_csv to load the data into a pandas table. The print statement tells us how many customers and pieces of info we have. df.head displays the top 5 rows so we can see column names and sample data. Running the cell now. You are doing great. See if the columns make sense to you before going on. Exploring the dataset. Understanding the info inside your data is a huge first step. Check out the features. Customer ID, unique number for each shopper. Gender, male or female. Age, years old. Annual income, $K yearly earnings, in thousands. Spending score, 1 to 100 how much they spend. Let us look a bit deeper. Running the cell now. Let us ask pandas to give us a numeric summary. Describe shows the smallest, biggest, and average values. Here we remove leading white space in the column names. Describe summarizes the data with quick facts. It shows average, minimum, and maximum values for age, income, and spending score. Running the cell now. Try to spot any value that surprises you. We want to know how many males and females are in this dataset. Value_counts counts how many shoppers are of each gender or group. Running the cell now. Knowing the balance of groups can reveal patterns later. Getting data ready for analysis. Some analysis tools only understand numbers, not words. So, we must turn gender into a number first. This is called encoding. Running the cell now. We give each gender a number, female is 0, male is 1. The map function replaces text with numbers so computer tools understand. Now we encode gender. We create a new column called gender_code. df, gender, gender_code. Head lets us compare text and numbers side by side. Running the cell now. Check the mapping below. Changing words to numbers is a must for most data tools. Not all columns help our clustering. We make a list of only the important numbers to use for grouping. We make a new table called X that keeps just those columns. We select only the columns we want for clustering. We include age, income, spending, and the numeric gender code. X now holds the values we will use for grouping later. Running the cell now. Less is more sometimes. Fewer columns can mean better clustering, especially for beginners. What is PCA? PCA stands for Principal Component Analysis. It helps us turn messy features into simple patterns. PCA finds the big trends and lets us see data in fewer dimensions. This helps with exploring and clustering. Running the cell now. Let us actually use PCA, but first we scale the data. Scaling makes sure every feature counts equally, no matter if it is age or income. Then, we keep only the top two principal components. These two numbers summarize most information in our data. Now, X_car holds a two-column version, perfect for plots or clustering. We import tools for scaling and running PCA. Standard Scaler puts every number on the same scale, so one column cannot dominate others just because of size. We fit and transform X to get everything ready. We set up PCA to find only two big trends, or components. Random_state makes our results repeatable. We fit and transform the scaled data to shrink its shape. Print lets us check that now each customer has only 2 values, instead of 4. Running the cell now. PCA can make it much easier to see clusters. Ready for a visual? Let us make a simple 2-dimensional plot of the PCA transformed customers. Each dot shows a customer, placed by their 2 main patterns. The hope is that we spot groups, or clusters. You do not have to understand all plot details, just sense the shape. We import Matplotlib for plotting simple graphs. We make a figure with nice size. Scatter makes a dot for each customer, using their 2 main PCA values. Labels and a title help us know what we are looking at. Plt.show actually draws the plot for us to see. Running the cell now. What do you notice in the plot? Can you see natural groups already? Time for clustering. What is k-means? K-means finds groups, which are called clusters, by first guessing where the group centers might be. K-means keeps moving the centers to fit real patterns. We will start with 5 clusters, just for practice. Running the cell now. We use scikit-learn's k-means tool to find 5 customer groups. Fit_predict actually does the learning and assigns each shopper to their closest cluster. We add a new column to the data so you can see which cluster each customer belongs to. We import k-means for clustering. We set up k-means to look for 5 clusters this time. With Fit_predict, the model learns from the PCA patterns and gives us a cluster for each point. We put the cluster numbers into our main data table. Now we can see which cluster the first few shoppers belong to. Running the cell now. Practice, how might having 5 groups help a mall manager? Let us check what our clusters really look like on a plot. We color each shopper by their group. Now we see if any colors make tight blobs. This lets you check if groups really seem meaningful. We make a new plot to show clusters. Scatter colors each dot based on group label. Set2 gives a gentle color palette for visibility. Labels and color bars help you see which group is which. Plt.show draws the chart. Running the cell now. Do some clusters look closer or more spread out? That can mean something important. Real-world use, what are clusters good for? Customer groups can help design special offers. Managers might focus on high spenders or certain ages. Not all clusters mean profit, always explore with a goal in mind. Running the cell now. Averaging each cluster tells us the typical customer type in each group. This helps you give each cluster a personality or nickname. We use Group B to break customers into clusters, then .mean shows typical values for each group. Running the cell now. Which cluster seems to have the youngest shoppers? Is there a group spending the most? Let us let you pick a group yourself now. Type a cluster number from 0 to 4. We will show a few shoppers from that group so you see details. We create a variable for the group you choose. Input asks you which cluster you'd like to see. We filter our table to keep just customers from the chosen cluster. Sample shows a preview of these people and their stats. Running the cell now. Type numbers one at a time and compare the groups. What do you spot? Now you get a taste of real-life discovery. Let us make our own group, young people who spend a lot. We set rules for age and spending. Then we count them and peek at a few. First, we explain the goal with a message. We create a condition to find shoppers under 30 and spending over 60 points. Young_high_spenders holds all shoppers who meet both standards. Print tells us how many there are. Head shows 5 examples from this young, high-spending group. Running the cell now. Mini project, try changing age or score rules and see what happens. Sometimes mistakes happen. Do not worry, they are a normal part of coding. Most errors come from typos or columns that do not exist. Let us show what a real error looks like. The next line is commented out to keep your notebook running. If you get an error, it might be because of quotes, spelling, or choosing a column that does not exist. The error message usually tells you where things went wrong. Compare the error words to what you wrote, and you will solve it faster next time. Here is an example of a line that would cause an error. It tries to print a column that does not exist in the data. Running the cell now. If you see errors, check the column headers in your table. That fixes most issues. A quick check for missing data is a smart first step in any project. ISNL finds missing blanks, sum shows how many per column. Knowing if data is missing can save you time and errors later. df.isnl checks if data is missing or empty. Sum shows a count for each column. Print gives a clear view if you need to clean anything up. Running the cell now. If something is missing, decide if you can fill it or need to drop it. You can repeat clustering with different group counts. Try 2, 3, or 6 clusters. This helps you see if 5 was the best number or if another choice feels more natural. We loop over a few different cluster counts. For each k, we set up k-means and predict clusters. Print tells us how many groups we made and the true unique values found. Running the cell now. Challenge, plot these clusterings and compare their shapes. If you found this lesson useful, remember to like and subscribe to our channel for more beginner guides. Recap and next steps. You have learned how to load, prepare, and group real customer data. You tried PCA for simplifying features. K-means found pattern groups to help businesses take action. Keep exploring and practicing new datasets. Running the cell now. Try more on your own. Can you? Plot age versus spending score for one cluster? Try other real datasets like Titanic or Iris. Change PCA to 3 components and plot? If you enjoyed this, subscribe for more Python and share your clusters below. Running the cell now.